We're showing how to make a very inexpensive conversion by removing the carburetor and letting the engine breathe without restriction all the air it can get on intake, so it'll have more air in the compression stroke and more air available for burning more fuel.
Now this is the 5 horsepower John Deere we were looking at earlier.
It is. It's shown now in the least expensive conversion mode, just using a delivery tube to bring the hydrogen right to the intake valve port. We're doing the control and thus the engine power control with a metering valve, which is a needle type valve, and it's common to the instrumentation industry where it would be used for controlling the flow of nitrogen or oxygen or hydrogen in a lab. But it's sized for delivery on an 1/8 inch tube. We then cut it down to a even smaller diameter at the point of injection.
This is about a 1/16 inch down here?
Well, it's about a 1/16 inch at the point of entry. But you can well do with even a smaller orifice, and I brought one that's for such engines as this, and you can see it as
we're going to zoom in on this real carefully.
As an example of the size of orifice we'd use for delivering the hydrogen at the intake port on a very inexpensive conversion.
So this is the size that you'd like to deliver through? It's
about the right size. Now you can come all the way over here with a 1/4 inch tube, make that final delivery just at this location on this
so we can come over to here
orifice.
with a 1/4 inch tube,
what
we have available, and then deliver through this small orifice or any other small orifice.
And you'll notice it resembles a type of hypodermic that would be used around a veterinarian supply. So you might think of picking one up from a veterinarian supply, or you might even pick up a bicycle, or I should say a basketball fill port.
But that's just a narrow tube. What's the outside and inside diameter of that approximately?
Well, it's about a 1/16 of an inch.
Internal?
Internal.
Okay.
So what else we're showing is the ability to run this on a basis of setting up one valve, that is the idle valve, and then you can set up a valve in parallel that gives you the ability to put this on a remote, on a foot feed, so that you'd set up the idle RPM at say 1,000 RPM.
So basically we're going to run hydrogen through this valve, which is the fine control needle valve.
That's right.
And that's going to be for our idle speed, where it's just enough to keep the engine spinning and spinning and spinning.
True.
And then when you hit this one, which is a full feed valve.
It is. This is a full feed valve.
But it's variable too. You can control it.
It's all the way from idle or off,
right,
where this is carrying the fuel, to much larger flow, maybe 10 times as much flow for acceleration and high-speed running.
So if you open this all the way up, it's going to go vroom and wide open throttle.
It does. And that way I'm just saying that you could put this on the foot feed, use this as a stationary...
Foot feed. Foot feed. You mean you're going to control this right here?
That's right.
With your foot?
That's right.
Well, that moves pretty hard. I mean...
Well, you just put that through a cable. You'll notice this one's equipped with a stop pin. You can probably focus right down on that stop pin.
Yeah, hang on, hold it up. Here we go.
When the pin's in place, you can't take it to full open. You take it to almost full open, but it always comes back. So that makes a very handy way to just put a lever to your foot feed position, and so the foot feed will still have mechanical advantage, and that turns out to be about the right tension.
Oh, you're right. My foot has a lot of strength on it. Plus, it's on the lever of the pedal. So
that's right.
Yeah, there would be.
But in any event, you can run it with a single valve or with 2 valves, as just discussed, and still be under $25 in conversion.
Under $25 to convert this engine right here?
That is right. And get more power than before.
More power.
And be able to run a fuel that you can make.
Okay. Now, is the conversion of this like 1 out of 8 on my 8-cylinder engine? So if I could duplicate this 8 times in my car, I could run my 8-cylinder engine?
Yep, you can duplicate everything we've said as many times as you have cylinder. Here's one for a V6. This is one bank of a V6, or it's for a 3-cylinder, as it turns out.
Your
Geo Metro.
Your Geo Metro that's on the DVD, that's a 3-cylinder,
It is, and the way we used this manifold, or one like this, at one point was to just do 3 times what we were doing here to run that engine.
So this could be, on a V6, this would be 1/2, and there'd be another one for the other half. or this just be by itself on the Geo.
That's right.
Or just one of these is what we're showing down here on
Yes.
the one-cylinder John Deere engine.
That's exactly right. Notice I'm using a flex tube to take out the vibration between the stationary delivery and the engine that gives motion for the engine to torque and to vibrate as engines will. So I'm not carrying a vibration or fatigue through my fittings.
That's stainless steel flex tubing,
It's stainless steel flex tubing.
easily available.
It is. This one happens to be a Teflon lined stainless steel reinforced steel tubing. And you can make them up yourself. You can build your own crimp tool, your own swaging tool, or you can have this swaged at a shop where they're doing this type of transition commercially. The other comment that I wanted to make in this regard was that in order to arrest vibration here, I've just run a longer length of this springy stainless steel.
It's not showing up that good on the video. Here we go. I can see it now.
Yeah.
So this is the intake tube. What's this right here? This is, what's this?
That's my kill ignition.
Oh, it's your kill ignition. So this is the kill ignition wire, and this is the actual tube carrying the hydrogen right here.
That's exactly right.
And this runs all the way over
To here, where I do the valving.
Oops, turn this around here. Okay, see, there's the tube right there. And there's your valve. Now
That's right.
Now this needle control valve, that would be your idle set. And you use this one to really change the speed, but you're using this one for both, aren't you?
Yeah, you can set them up so that you can do everything on a hand valve, or you can do a combination of the hand valve for idle and this type of
Oops,
acceleration.
I had the wrong one.
Yeah.
I'm sorry.
This type of acceleration.
This is the idle
That's right.
type of valve, and this is the acceleration type of valve.
That's right.
And you're doing everything, it was just that one right there.
That's right. Now the other thing I wanted to cover in this regard is you can do your own timing off of an engine such as this one by removing the flywheel, removing the key that makes it for the gasoline setting, and then relocating that key for a later ignition. And you can then either use a half key for the offset, or some fraction thereof, or you can mill a new slot for your new setting for hydrogen.
Okay. And that's internally in the engine, though.
That's internally in the engine, but it's a quick conversion. The other alternative is to change the magneto timing electronically. You can do a delayed off for the flow of current to the coil and run this as a Kettering type of ignition with an external coil.
So either way, you're going to have to really change your timing on the engine if you want to take full advantage of the hydrogen.
You'll time to a later point of ignition.
Pretty close to top dead center.
Pretty close to top dead center is correct. And you'll, by doing so, save a lot of heat that would have been lost to the combustion chamber surfaces.
Who makes the ignition delay type of thing you were talking about? Instead of changing the timing in the cam that fires the spark plug, we're talking about delaying the signal from here to the spark plug with electronics.
Well, there are a number of companies that make ignition control systems, but ordinarily they make them for advancing ignition. We use it for delaying ignition. One such source is Autotronics.
Autotronics, A-U-T-O-T-R-O-N-I-C-S?
That's correct.
They're on the web?
They are. And there are others. But you can make one out of a Radio Shack source 555 integrated circuit.
Wouldn't performance automobile shops carry some of those parts as well?
Oh, a lot of them carry a variety of different brand name ignition control systems. These are usually, again, for engines that are burning slow, burning fuels such as gasoline or methanol.
Also, before you run your car on methanol, like if you're a top fuel dragster or a weekend dragger, you're going to have to change your timing.
You'd have to advance timing.
Okay.
But here we're making it so that we get a much higher thermal efficiency and a much greater use of the fuel, producing more power than before by making a later ignition because we have a much faster burning fuel. Well, those are the points that I wanted to go over, Steve, and show that you can have a very inexpensive conversion.
Okay, we'll move to the next subject.
Good.
Okay, now one part I want to reinforce for the viewer. Again, how exactly does the conversion of the single cylinder apply to how they're going to convert their vehicle, where it's a 3-cylinder Geo a 1987 Dodge truck or an old Cadillac with a carburetor or a new vehicle, how are they going to use this to start their conversion on their vehicle?
Well, every one of the vehicles that you mentioned have a number of one-cylinder engines all put together as a V8 or put together as a three-cylinder inline Geo, as you mentioned, or a V6 or an inline four, whatever it may be.
Mm-hmm.
But here are the essential components. You make the decision on how you're going to operate the fuel storage, how you're going to operate the delivery of the fuel and metering of the fuel, more or less like we do on this one cylinder.
So this mechanism right here would control the flow to all 8, all 6, or all 4, or all 3, or all 1 cylinder.
That's right. You can make this so that it was manifolded, so that it could be the entire system. And it can be manifolded for a hand valve, or it can be manifolded for a combination, as we mentioned, of a foot-feed operated flow valve that gives them the ability of this system to do everything that is in your automobile today off of a single control for high-speed operation and a single control for idle.
Now, isn't it exactly this valve right here that is in your Geo outside that we were driving around in?
It is.
It's that valve that you were driving with all those fuels on, and it's basically this manifold right here that we were driving around on.
It is.
On that Geo that we were having fun in.
Yes, it is.
That's simple.
Yes, it is.
But the timing has to be advanced.
The timing has to be not advanced, it has to be slowed to near top dead center.
Okay. So advancing the timing is going away from top dead center, and slowing the timing is going toward top dead center then.
During the compression stroke, if you slow the timing, you're moving towards top dead center. If you advance the timing, you're moving towards bottom dead center.
Okay, I got it.
We're showing here again to remind the person that might be doing this of the essential components, starting with the tank for storage. We're using a carbon tank in this instance. We're showing how to fill with a port that enables the Geo to be filled in 4 minutes.
Which we did show on the previous section of the DVD. We filled that tank in a second or two.
That's true, but if it was a larger tank as we have on the Geo, it'd be about 4 minutes.
Okay.
It's about 4.5 minutes for the even larger tank that we used from the pickup truck. This is a regulator for delivering the fuel to somewhere else, but this, in this instance, is to a one-cylinder engine. And we're showing how to then to break down the final delivery for a piston and cylinder. It's about the size of this one-cylinder engine.
We've talked about getting tanks from Lincoln Cylinders in Nebraska, and an SCI, which is Structured Composites.
Structural Composites Industries.
And they're in what city and state?
They're in California.
They're in California.
I think they're in Pomona.
Okay, so someone's going to get a tank like this, well, much bigger, and they're put in their vehicle. What do they need to know about regulators? Because they need to regulate down the pressure to go to the needle valve, to the orifice, and to the engine.
Well, you probably use two regulators for a two-stage drop down. The first one may be in the tank itself. It may be hidden in the tank. And from it, you may deliver to a relatively low pressure, such as 100 psi. And then from that 100 psi, break it down to what you're going to do in final delivery.
So what's the first regulator, if they don't have one in the tank, what's the first regulator range that they must have?
It must be the upper limit of what you're going to fill the tank to in pressure. So if it's a 10,000 psi tank, you'd need to be able to...
Well, let's say more commonly, a 3,500 psi tank is going to be more within the reach of people getting. It's going to be a fiberglass wrapped aluminum tank, 3,500 psi. What's the they get a regulator rated for 3,500, excuse me, 3,500 psi. What's the bottom output of that regulator going to be at?
Maybe in the neighborhood of 100 psi.
Okay, and then from that, after that, they need to get another regulator that will handle the 100 psi in.
That's right.
And deliver what controlled pressure out.
Well, if you're going to run like we did here on manifold only, it's going to go down to a few psi.
Okay.
From this valve, I only have about 5 psi coming in, and I have a few psi, 2 psi going out.
So this valve right here, you got 5 psi going in.
That's right, and it's a depending on how much I am cracking it, it has an effective pressure drop across it. At full open, however, it's running virtually the same as the regulator would deliver.
5 psi.
That's right.
For this one-cylinder engine.
That is right.
How many psi would you run for an 8-cylinder engine, like you want to convert your Cadillac?
It would be the same. I would just, in that instance, have a different orifice, final orifice, on letting more come into the engine. But the cylinders are about the same size, it turns out.
So basically, you can start at around 5 psi for your delivery pressure.
That's right.
No matter what you're doing with a 10 gajillion psi tank,
Yep.
you want to get it down to about 5 psi
That's right.
in the final application.
That is right. Now that's for these type of deliveries to produce a homogeneous charge. For a stratified charge, we're running higher pressure on entry.
Uh-huh.
And then we're typically running, depending on the size of the combustion chamber, 100 psi over max compression.
Uh-huh. But
If it was a diesel engine, for instance, you'd run over a higher pressure than you would for a low compression spark ignited engine.
right. So about 5 psi right now is where the people are going to be starting.
That's right. Now we mentioned electronic timers.
Yep.
On this kit of components, we're showing virtually everything that you'd have on your Cadillac or your Geo or your lawnmower, for that matter, by way of a Kettering type ignition, meaning that it is a battery with a interrupted flow of current to a transformer, which we call the coil, to increase the voltage to spark voltage, as we see here. So what we're doing is moving, in this instance, from 6 volts to about 20,000 volts through a type of transformer that's an automotive, as we call them, coils.
Okay, so here it is right here on the bottom.
The device that does that is a homemade brain, so to speak, and that again is, in this instance, is using a 555 integrated circuit to do the interrupted flow of current, which serves then as a change of flux through the...
There's off-the-shelf units though for doing ignition off of 12 volts, isn't there? From the automotive supply store, they got the oscillator already built into it.
Oh, there are many, many, many already off the shelf.
So you don't have to build it. You can actually go buy a spark system.
Well, it depends on whether you're an electronics-oriented person or you want to go buy the componentry. They're both available, and they're both, as you see, compact and able to go from small voltage to high voltage for the purposes that we have in
How many volts is this again?
about 20,000.
20,000. But that's the voltage of any spark plug in any car as well.
Sure. And it's typical to the voltage that's produced by a magneto in this one-cylinder engine.
Mm-hmm.
We would recommend that everyone start with one of these one-cylinder engines because they can become a friend in need as a rescue unit in the...
But this is the learning point. Before you convert your vehicle, convert a $200 or $100 or
Sure.
one that you pull out of the junk from someone's
Sure.
lawnmower. Convert one of those engines first. And
That's
everything
right.
you learn on here will make your automobile conversion so much more easier.
That's very true. And you can buy hydrogen to fill your cylinder at a number of places. We're seeing cylinders filled at Praxair, at Air Products, at Air Liquide, and a number of welding supply houses where they will load such cylinders quickly from bulk storage or from cylinder storage that they have
But
on
the
hand.
welding supply house is your last choice.
Well, it depends whether they're servicing from their own sources or just
Someone
a dispenser.
else's, yeah.
But I'll tell you, here in town, you can also buy from the local utility. Arizona Public Service will sell pure hydrogen for about $2, a little over $2 a gallon equivalent.
So you're paying $2 for a gallon of gas equivalent, which we call GGE. That means you're paying $2 for the amount of hydrogen in a standard engine that would take you as far as the amount of energy in 1 gallon of gasoline.
Well, if you're measuring precisely the amount of heat released, that would be a GGE. But the
Right.
GGE in the form of hydrogen, with what we have shown here, will go further than a GGE out of gasoline.
Right. So
Because
it's
we get
a
a higher-
standard engine, the GGE applies. Now, when we start talking about doing high boosting, stratified charge rather than homogeneous, and changing your timing, that's what makes the H2 GGE a little bit better than the gallon of gasoline.
That and running unthrottled. Unthrottled is remember, all the air come into the engine that can come in without restriction, on idle, on acceleration.
Basically, take the carburetor or the throttle body off.
That's right. You take off the throttle, you get more air, you can add more fuel when you need it. But the best of all is that you lose less of the engine motive power making a vacuum than before.
Right, and if you don't know what we're talking about, go back to the first 30 minutes of this the first 30 minutes was on internal combustion engine fundamentals, and we're referring back to those first 30 minutes that you skipped by right now.
Well, in any event, know this. If you don't pull a vacuum in the engine, you can make it much more efficient. It'll produce more power. It'll last longer. You'll use less oil, and it gives you the ability to insulate
So it's
much of the fuel
it's the
combustion.
throttle plate in the throttle body or the carburetor that's forcing us to pull a vacuum, which is making us do work when we don't need to. By taking that off, you have a free flow. It's like putting your hand over your mouth. If you inhale with your hand over your mouth, you can feel the suction trying to pull your hand back in, which is really not your lungs trying to pull your hand back in. That's your negative pressure you're creating with your lungs. It's the outside air pressure trying
Right.
to push back on your hand.
It's very true.
So that's the same type of back work we're talking about.
We are. Running unthrottled.
It's like
has-
taking your hand away from your mouth and breathing normally.
That's right. Well, it has the ability, furthermore, to greatly improve the cleanliness of the engine.
Mhm.
By not pulling a vacuum, you don't have the pressure drop across the seals from the outside pressure to the vacuum that carries with it oil that oftentimes is very abundant, as you can see it, during deceleration of the engine. So when
Right.
you have the vacuum produced by deceleration is when you notice that the blue smoke rolls out of these engines that are losing oil.
You know, they're losing oil or mistuned or getting older and worn out.
Sure.
So look for that when you're driving down the street. Look for the blue smoke coming out, and you're going to know that the guy is deaccelerating.
That's right. Well, what we noticed in this regard was the ability to take a forklift that was in a local manufacturing plant and had been quarantined because it was a source of oil that would condense on surfaces that had to be maintained very clean for their operations. So we took off the ability to produce a vacuum. We took off the throttle and all of the other restrictions to the entrance of air into the engine. Without a vacuum, and by doing direct injection, we were able to clean that engine up to the point that it was an air cleaner. It was a positive effect on
Again,
the air in that plant
You're running on hydrogen,
by running on hydrogen.
right?
That's true. So by moving from propane and vacuum operation and over to non-throttled operation, non-vacuum operation, we were able to make it an air cleaner instead of an air polluter.
And again, we are referring to the first 30 minutes that we talked about extensively with taking the throttle off, and you can see that illustrated on the whiteboard.
Well, you can see that illustrated on the whiteboard, but you can also know that with your own hands on engines that you convert.
Thank you.